Okay, shifted parabola. Have equations of that form. What we want to do is we want to be able to write the three types of equations that we have. We want to be able to understand the difference between each one. There's one that isn't added into here, that's circles. And that's fine. Circles are really no big deal. They're basically like ellipses. It's just that the A and B value are the same. That's all the difference is. So if you think of an ellipse and the A and the B values are the same, then we go on the same amount in the X and the Y, right? So basically, if you know how to do ellipses, you know how to do circles. So we won't add that in. Okay, an ellipse is going to have an equation in the form of x minus h quantity squared over a squared plus y minus k quantity squared over b squared is equal to 1. Who can tell me regarding the equation I just wrote down for shifted ellipse, is that going to be stretched more vertically or horizontally? Horizontally, why? Yeah, a squared has to be larger for ellipses, and so x is underneath, or a is underneath that, okay? So hyperbolas is just going to be slightly different. It's just going to be a subtraction sign. X minus h quantity squared over a squared minus y minus k quantity squared over b squared is equal to 1. Is that one going to be, is it going to open up horizontally or vertically? Why? Good, x is positive. In all these cases, here the vertex is located at hk, and the ellipse, the center, is hk, and in the hyperbola, the center is hk. So let's determine one from the other. Let's determine one from the other. What makes the parabolas different from the other two? Tell me something about it. Logan? Okay, they're solving for x or y. What else? Yeah. Okay, no fractions. Suppose that it was written in this form. I will tell you right now that this is either a parabola, an ellipse, or a hyperbola. What type of characteristics would you look for in here to determine whether it would fit into an equation of this form, or this form? Okay. What about exponents? Tell me more. Very good. So what Brooke is seeing here is that the x is squared and the y is squared. Look at the ellipse and the hyperbola. The x is squared and the y is squared. X is squared, y is squared. But the parabolas, only one of the two is squared, right? So if you have an x and a y squared, or a y and an x squared, then you know it's going to be a parabola. So if only one is squared, parabola. So what would then be the difference between the ellipse and the hyperbola? Yeah, so if you have x squared and y squared where both are positive, then it's an ellipse. But if you have x squared and negative y squared, or negative x squared and positive y squared, then in that case, it's a hyperbola. Your ability to look ahead and to determine that is crucial. And notice that it matters on which side of the equal sign everything is on. So right now, by looking at this equation, is it going to be a parabola? No. Why? Both are squared. Is it going to be an ellipse? No. Why? Because the y here is negative. So it's going to be a hyperbola. If I wrote it as 9x squared minus 72x equals 16y squared plus 32y plus 16, then they would both be positive, right? But it's still a hyperbola. So when we talk about one being negative, that means as they're on the same side of the equal sign, okay? So that's what's important. So we know that we are going to put this into the form of a hyperbola. We have no idea how to determine the foci, the center, the length of the transverse axis, the asymptotes, if it looks like that. But if we can place it into this form, then we can determine all sorts of characteristics and qualities about it. So let's go to work and complete the square. I'm going to group the x's together, and what can I factor out of the x's? A 9. Yes. However, you will remove the squared then, and we want to be able to complete the square. So what do you take out of the y's? Negative 16. And you're left with y squared plus 2y. Complete the square. What number do I add to complete the square? 16. What is the true value of that 16? 9 times 16 is 144. Remember doing that first semester? And that's why we practiced it, to get good at it, so this wouldn't be as hard. Now, what number do you add here to complete the square? What is the true value of that 1? Negative 16. So we now have this. 9 times x minus 4, quantity squared, minus 16 times y plus 1, quantity squared, is equal to 144. The 16s cancel, works out quite nicely. What do I have to do now to put it in the form that we want? Then I get x minus 4, quantity squared, divided by 16, minus y plus 1, quantity squared, divided by 9 is equal to 1. Now that it's in the form, I can identify all the important characteristics. Like on your study guide, you see here that all the characteristics are listed for you, right? So I'll have 3 problems where I list everything for you. But I will then have 3 problems where it's not listed for you. And once you determine what it is, you'll go back and look at what you wrote down for the others and say, oh, that's the information I need to provide, right? Otherwise, if I use the term eccentricity, you would know ahead of time that it would be an ellipse. If I use the term latus rectum, you would know it would be a parabola. And if I use the term asymptotes, you would already know it would be a hyperbola. So I don't tell you ahead of time so you don't know what it is. So you would go back and gather that information. So we're looking at direction. Yeah, so like I said, I will put all these characteristics down on the first part of the test. But when you get to the last 3, I won't list them. You'll see them on the first 3. And so you'll grab them from there. All right, direction. We also have center. We have vertices, length of transverse axis, asymptotes, and foci, and a graph. All right, direction. Horizontal or vertical? Why? Because the x is positive. You could tell that right away, couldn't you? All right, center. Or -1. I'm going to now plot my center and make my Tanner rectangle. Tanner wants it named after him. He's kind of specific. Going to make Tanner rectangle. 4, and then it looks like we're going to go 4 in each direction. So if I make an 8 by 8 grid, that should be enough for the work I'm doing. Raylan, would you like something in mathematics named after you? Which is, you know, it's like, all right. I want you to know that math loves you. So, okay. Okay, we plot it. 4, -1. How many units do I go in the x direction? 4. How many units do I go in the y direction? It's going to make my Tanner rectangle. Tanner said he's glad he's not in this hour anymore. I told him it was insensitive, but he just said it. He says a lot of things. All right. All right. So I also sketched my asymptotes. So the vertices, will they sit on the sides or will they sit on the top and bottom? Sides, because it opens up horizontally. So I'm going to put them right on the sides. And what is then the location of those vertices? 0, -1, and 8, 0. No, 8, -1. Got it. I will now make my shape, since I know my vertices. Length of the transverse axis is the distance between the two vertices. What is the distance? 8. The asymptotes. Please do not get this wrong on the test. I get a lot of these incorrect because people are like, I don't even know what to write. It's not that bad. Y minus k equals plus or minus m times x minus h. So y, what's the k value? -1. So we got +1 equal to x minus h. What's the h value? 4. -4. Plus or minus, how do we calculate the slope? We look at the Tanner rectangle. What's the rise? 3, run? 4. So 3 over 4. Now we're left to the foci. What value do I have to find that I do not yet know? C. What's the equation for C for a hyperbola? A squared plus B squared. Very good. And if you take 16 plus 9, you get 25. So C is 5. So I move 5 units horizontally. So the location of the foci are -1, -1, and 9, -1. What do you think? Not too bad? Yo. Yeah. That's the answer. Flip it. Some more. What's the shape? How do you know it's a parabola? It's only 1 squared. Awesome. I know what I'm going towards now. Here's where people often make a mistake. They add the 28 and they divide by the 8 and then they try to complete the square. Are you trying to complete the square for x's or are you trying to complete the square for y's? Just the x's. Well, it's already set up where you just have the x's together, so just complete the square right now. What number would you add to complete the square? Yeah, I'd take the middle number, divide by 2, and square it. So 4 divided by 2 is 2, squared is 4. What's the true value of that 4? 4. That was easy. So x minus 2, quantity squared, is equal to 8y minus 24. Now what? Add 24. So we got x minus 2, quantity squared, plus 24. equal to 8y. Now what? 5 by 8. Do I divide the first part by 8, the 24 by 8, or both by 8? Everything. Thank you. So y is equal to 1 over 8 times x minus 2, quantity squared, plus 3. Awesome. List all my characteristics: direction, vertex, axis of symmetry, focus, directrix, length of lattice, rectum. Direction. All right, good job. Yeah, it is up. I thought if I looked at you really tough like that, I'd get somebody to say right or left or something, but good job. You're convinced. Way to go. It's up because it's y equals, so it's vertical, and this is positive. The vertex. 2, 3. At this point, I start plotting, okay? And if you kind of peek ahead of time, you can tell that the p-value is going to be 2. So therefore, you know, if I move 2 units then from each of these spots, 5 would be the furthest. So if I make it 8 by 8, will that be big enough? Yeah, so I'm just trying to get a reasonable idea of how large I need to make this graph. Now, I know Darren's watching to make sure that I do a good graph. And so I will say that second hour or third hour, it was pretty pathetic. I'm all about self-deprecation. We're all given our off days. Well, it's good enough. Okay, what? Oh, over we go. Okay. Joni, speak up again. I'll put a marker on your face. All right. All right, here we go. Okay. So I plot the vertex at 2, 3, over 2, up 3. And then the axis of symmetry, is it going to go vertical or horizontal? Because it opens up, it will go vertical. And so I draw it, and then I name it. Name that line. Yeah, I'm so proud of you guys. I'm getting nervous. Okay. In order to find the foci, in order to find the foci of the directrix and the length of the lattice rectum, what value do I need to find that I do not yet know? P. Oh, my. Remember anything? So, you set up the equation. A, or 1 over 8, is equal to 1 over 4p. I solve for p by cross multiplying. 4p is equal to 8. Divide by 4. P is 2, which you already stated earlier. Help me make my number of tick marks I needed. If P is 2, that means I move 2 units in the direction for the focus. So because it is up, I move 2 units up. That's my focus. This is my vertex. What is the location of my focus? 2, 5. What do I do for the directrix? 2 units down. Is the directrix a point or is it a line? Is it parallel to the axis of symmetry or perpendicular? Good job. So directrix would be an equation of y equals 1. Again, x equals and y equals. These should be perpendicular. Length of the lattice rectum will be the absolute value of 4p. Absolute value of 4 times p 8. So I will be 4 units in each direction. It opens up vertically, so I have to know how wide to make it. So I move horizontally. Stop, 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 stop. All right. The absolute value of 4p. All right, I'm going to draw it. And I will check. That distance should be the same as that distance. I don't even check it. It's horrible. Fail. I can't because I didn't lift my finger between when I made the two segments, so now they're connected together as an object. So, all right. Give up. All right, we'll do the last one. Is it a parabola? Why? Because both are squared. Is it a hyperbola? No, why? They're both positive. So therefore, it is both positive, so it's an ellipse. Let's complete the square. Factor out a, very good, x squared minus 6x what do you add and complete the square? Oh. You'll see. The reason why you can is because 2 times x squared, there it is. 2 times negative 6x, there it is. Y squared. Because the addition, this is just a distribution, a multiplication. It's not going to distribute to there. Okay. All right, what do you add to complete square? 9. What's the real value of that 9? What's the real value of that 9? So therefore, we have an equation of 2 times x minus 3 quantity squared plus y plus 3 equals 1. Now, you are used to having ellipses where it's equal to something else and you divide through, correct? But it's equal to 1, and so I mean, we're basically done. We just want to write it just a little bit differently. So I'm going to write it like this. Y plus 3 quantity squared over 1. So that way my value under the y's is 1. And then a little trick here. Instead of multiplying by 2, I could write it as divided by 1/2. I think you had one like that in your assignment. And you probably either had an aha moment or you saw it in the book or you just did it incorrectly, did check your work. So if you have a number like that in front, you gotta go back and make sure you got that right. So we don't ever leave an improper fraction in mathematics. That's why you write the 2 up there. However, for the sake of understanding how to graph this, we want to write it as divided by 1/2. So here comes tan dog. All right, so we are going to have direction and center. What up, buddy? I told them how you said that you are glad you're not fifth hour anymore, and they were a little angry. Ooh, ouch. We named the rectangle after you, though. So, yeah, we're going to try. Okay. Direction, up, down, right, left. What is it? This is vertical. Why is it vertical? This is larger than this. Very good. What's the center? Now, I can see that the largest number of units I move is just one in each direction. So 1 in the y direction would bring me up to -2 and down to -4. So if I simply just make 4 tick marks here, that's going to be enough to be able to see the entire graph. And it's all located down in the 4th quadrant. Oh. Sean, can you check on them, please? All right. All right, what should I plot? 3, -3. Got it. Okay, I'm going to have vertices. I'm going to have major axis. I'm going to have minor axis. I'm going to have foci. And I'm going to have eccentricity. How many units do I move vertically? 1. How many units do I move horizontally? 1. The square root of 1/2, which is 1 over the square root of 2, which is the root of 2 over 2, or 0.7071. So 0.7071 is less than 1. It's about 3/4. Can now make my graph. Every year I do this, it turns out so bad. I actually think that's the best one I've ever done. I think this is my best one. Like I've been trying 5 years. That's all I get. All right, location of the vertices. 3, -2, and 3, -4. Length of the major axis, 2. Length of the minor axis, or 2 over 1 times the root of 2 over 2, which is just the root of 2, which, as you guys says, 1.41. Foci. What's the equation? A squared minus b squared is c squared. So if you take a squared, 1, minus b squared, 1/2, you get 1/2. And what's the square root of 1/2? 0.7071, or the root of 2 over 2. So what I'm going to do is I'm going to move 0.7071 units, or 3/4 of a unit, approximately, vertically in each direction. Does that change the x value or the y value of the center? So I still have 3, and then I have -3 plus or minus the root of 2 over 2. If you would like to calculate those as decimals by adding and subtracting 0.7071, that's fine. Finally, the eccentricity. I take the c value, which is square root of 2 over 2, and I divide it by the a value, which is 1, and I get root of 2 over 2. So I like this problem because the root of 2 comes up a lot, and that does actually within trigonometry, so it's neat to see it all the way through. But there you have 3 examples. You can see that these should not be taken lightly. that we should work hard to make sure that we know them well, which is why I'm just giving you 3 problems today and 3 problems Monday, and you have your study guide. But own these and make sure you're doing them well. It is 50% of your test. There's your assignment.